square roots. Okay? We need to know what rational and irrational. We need to talk about rational and irrational numbers. Okay? Need to talk about rational and irrational numbers. Now, a rational number is a number that can be written. You need to write this down. A rational number is a number that can be written as a quotient. I'm fixing to tell you. Basically, what they're talking about when they say the word quotient, they're talking about it can be written as a fraction. Okay, a quotient is a division problem. Okay, it's the answer to a division problem. Okay, but a quotient, basically, they're just saying, can I write that expression as a fraction, whatever our answer ends up being, okay? I'll give you an example of that, okay? If I take the square root of 36, the square root of 36 is what, Noah? Noah? 6. Square root of 36 is 6, okay? Can I write 6 as a fraction? Yes, I can. What is it as a fraction? 6 over 1. So, therefore, it has to be a rational number. Okay? Let's talk about this one. Square root of 32. Is there a perfect square that is a square root of 32? No, it's not. Okay? So, therefore, it is an irrational number. So, the square root of 32 will be irrational. Okay, let's talk about what irrational is. Okay, an irrational number is a number, write this down. An irrational number is a number that cannot be expressed as a quotient. Okay, an irrational number is a number that cannot be expressed as a quotient. Okay? Or, once again, a fraction. Yeah. Okay? So, we already talked about the square root of 32 is irrational because it doesn't have a perfect square. Okay? So, basically, irrational numbers are those numbers, okay, write this part down. Irrational numbers are those numbers that are infinite. Okay? They're those numbers that are infinite. Okay, same thing as infinite. Okay, an infinite number is a number that never ends. Okay, it never ends. All right, for example, I'll show you real quick here. Let's go to the calculator and we say, okay, 32, the square root of 32. There's the square root of 32. That's why it's an irrational number. The square root of 32 is 5.656854249. And you will see that, does it repeat the same digits? Yes, there are digits that do repeat. But they do not repeat in the same order. Okay? And so it just stops because it's run out of places. Okay, it would go on if you had enough space, Drew. If you had enough space, it would go on forever. Okay, It would just continue on. It wouldn't repeat the same block of digits, and that is why it is irrational. Now, how do they show an irrational number in your text? Okay, they will show an irrational number in your text like this. Well, the calculator is using logarithms and other things of that nature. It's not figuring out it's not saying here is the number. It's saying if I do this, what digit comes up. And so it's just processing those digits and going, okay, this digit comes up, this digit comes up, and it's going to keep giving you digits for however many places you have. Now, on the old calculators that only went out 7, 8 digits, it would come up and it would say, it'd have the 8 digits, or it'd go 1.256e to the 10th. And what that's telling you is it would go out 10 more places, but we don't include those numbers, basically. And so, or it would write it in a calculator form of scientific notation a lot of the times as well. Okay, now, remember our whiteboard's used for math stuff, not doodling or coloring. Okay, so this would be an irrational number. So this is irrational. This is rational. Okay, this is rational. Why is 1.35 rational? Well, can I express 1.35 as a fraction? Yes. It's 1 and 35 over 100. Or it's 135 over 100. Or you could reduce it and all that. So it is a rational number. Okay? This also is a rational number. Because it's 1 and 35 over 100, as I just said. Okay? Now, 1.3 with a bar over it is also rational. Okay? Because 1.3 with a bar over it is 1 1/3, which is the same thing if I wanted to take it to its full 4/3. Okay? So repeating decimal numbers are rational numbers. Okay, repeating decimal numbers. So a rational number is a number, basically any kind of decimal that doesn't go infinitely. Okay, the only ones that are irrational are those numbers that are going to go infinitely. Where we see a lot of irrational numbers is what we're talking about today, and that's in square roots. Okay, so that takes us to our last point, approximating square roots. Okay, approximating square roots. Okay, approximating square roots. Here's what we're looking at. Let's say I have the square root of 18. Okay, well, I can plug in the square root of 18 into our calculator, and it'll come up with a huge, long number that has, an infinite number of digits in it. What they want us to do is they want us to approximate the square root to the nearest 10th. Okay, here's how we're going to do it. The first step is this. Step 1. Find the two perfect squares that your number falls between. Okay, so the square root of 18 falls between the square root of 16 and the square root of 25, which is 4 and 5. Okay, so that's the two whole numbers, or the two perfect squares that our square root falls between. Okay, so we know then that the square root of 18 is going to be 4.1, 4.2, 4.3, 4.4, 4.5, so on. Okay? All the way up to 4.9. We know it's not 4, and we know it's not 5 times 5. Now, the next step is see which square root your number is closer to. Okay? So, what I want to look at then is the square root of 18 closer to the square root of 16 or closer to the square root of 25? So, is 18 closer to 16 or is it closer to 25? 16. It's only 2 away from 16. So, therefore, I know this. 4.5 is right in the middle. Okay? So, to be right in the middle, though, I would have to have a number that's closer to 20. Okay, 21, 20, the square root of 20, square root of 21 would be sort of in the middle. So we know that our answer then falls on this end of the spectrum. So we know that our answer is going to fall somewhere in that range. 4.1, 4.2, 4.3, 4.4. Okay, we also know that 18 is fairly close to 16. So I'm going to hedge a guess that it's somewhere right in here. Okay? How do we find out? Well, that's the part that stinks. You just got to multiply it out and see. Okay? So I want this group here to multiply 4.2 times 4.2. I want Nikki's group to do 4.3 times 4.3. Okay? This group do 4.1 times 4.1. Y'all do 4.4 times 4.4. Okay, do it real quick. Come up with the answer. Make sure you've got an answer that everybody has in your group. All right, what y'all have? What numbers? 4.2? So you had 17.64. Okay. Nikki, what's 4.3 times 4.3? Okay, what y'all get for 4.4? Who had 4.4? Y'all did? Which is it? Y'all got to decide. I need an answer that y'all agree on. 19.36. What's 4.1 times 4.1? 16.81. Okay. And what do we get for 14.3? 4.3 would be 18.49. Okay. Now, those are our numbers. What we have to decide is we're looking for the square root of 18. So which one of these two are closer to 18? Really? Okay, hang on. Write it on your whiteboard and hold it up. What you think is closer, write it on the whiteboard and hold it up. And hold it up where I can see it. Now give me the 17.64 or 18.49. Don't look at anybody's. Tell me what you think. Oh, yeah, Joshua. Okay, so most of us are looking at 17.64. Okay, so 17.64 is 0.36 away from 18. 18.49 is 0.49 away from 18. So this is the closer one. So the approximate square root of 18 is 4.2 plus or minus.
So that's the sign we use for approximate?
No, that's wrong. I forgot the little second one. It's like this. The approximate square root, this means approximate, okay? The approximate square root of 18 is negative plus or minus 4.2, okay?
Wait, you have to put the square root of 18 in?
Mm-hmm. All right, now, let's look at this one. Square root of 125. I want you to do that one with your group. Do the square root of 125, okay? When you have an answer, put it on your whiteboard and show it to me, and then I will tell you whether or not you can check it, okay? So do the square root of 125 with your group. You got 5 minutes at the most.
Coach, how did you figure out which side it fell on?
Do what?
How did you figure out what side the square root fell on?
Is 120, well, no. Make the square root of 11 is what? The square of 11 is what? 121, right? Okay. So that is 144. So is it closer to 121 or is it closer to 144? So y'all got it?
No.
I mean, no. Do you getting there? You understanding what you're supposed to do? Okay. I just want to make sure you're understanding what you're supposed to do. Hmm.
11 point.
So, once again, it fell between the square root of 121 and the square root of 144. That's where it fell between. Okay, now we know square root of 121 is 11, square root of 144 is 12. Okay, and so we know that it falls in between those two. We know that 125, if we do 125 minus 121, that's only 4. So it's 4 away from 121. So we know it's going to be on this lower end. If 11.5 is here, it's going to be on that 11.1, 11.2, 11.3 range. Now, it's always important to make sure you check the surrounding numbers when you multiply it. Okay? Because there could be one that's closer. Okay? So don't just assume, oh, I'm only 0.4 off, so it's got to be it. Could be, but you need to check the one below it. If you're above it, then check the one below it. If you, in other words, you did 11.3 times 11.3 and got 125.79. Okay, well, that's obviously above 125, so I got to check 11.2 below it. Okay, that's how you would check it. All right, your homework. You've got 11.2 6 through 18, and 21 through 30.
You have to do both of those, 11.1.
And then you have 11.1, what was it, 38?
38, 42, no, 43. Yeah, 43.
Of course, we've done, at 11.1, we've already done all but one of them, or two of them. Okay? So, listen to me. Focus. Both of those are due tomorrow. Okay? So put your desk back and you can go. Make sure you turn your devices off so they don't go off in somebody else's class that's not using them today.